Next example, list all integers x in the range 1 less than or equal to x less than or equal to 100 that satisfies x is congruent to 7 module 17. That is, we have to find the values of x from 1 to 100 that belongs to 1 to 100, and that satisfies this equality. That is, x is congruent to 7 modules 17. That is, that numbers x congruent to 7 module 17. And you know that when x is congruent to 7 module 17, if 17 divides to x minus 7, and when 17 divides to x minus 7, the by using definition of divisibility, x minus 7 expressed in the form 17 into some integer for some k belongs to z. That is, when 17 divides to x minus 7, if x minus 7 expressed in the form 17 into k for some k belongs to z, and then x is equal to, what do we have, x is equal to 7 plus 17k. That is, we have to find the values of x that satisfies this equality. That 7 x is equal to 7 plus 17 into k, k belongs to z. That is, substitute k as a integer. And what is the set of integer? Is the set of integers is 0, 1, minus 1, 2, minus 2. That is, if you start from minus infinity, then set of integer is what? Is minus 1, minus 3, minus 2, minus 1, and so on. This is the set of integers. What is the set of integers? This is the set of integers. Minus 3, minus 2, minus 1, 0, 1, 2, 3. That is, substitute sub first z as minus 3. This is the set z. So this is the set z. Substitute the values of z from this set. That is, substitute z as minus 3, minus 2, minus 1, 0, 1, 2, 3. So what is 7 bar? Therefore, what is 7 bar? The 7 bar is what? Is the set of, what is 7 bar means what? Is the residue class of 7, module 17. So what is the definition of 7 bar? Is the set of elements from z such that x is congruent to 7 module 17. So those satisfies this equality, x is congruent to 7 module 17, are the elements of 7 bar. That is 7 bar. How you can find 7 bar? Substitute z dash substitute z as value of this small k as minus 3. So what do we have? 7 into 17 into minus 3. Then substitute k as minus 2. So what do we have? 7 plus 17 into minus k means this element, 7 minus 2 into 17. That is, substitute k as minus 2. Then substitute k as minus 1. What do we have? 7 minus 17. Then substitute k as 0. Then what do we have? 7 plus 0. 17 into 0 means 0. That is 7. Then substitute k as 1. Then what do we have? 7 plus 17 into 1. That is 7 plus 17. Then substitute k as 2, element 2. Then what do we have? 7 plus 2 into 17. In this way. And so what we have the element? This is minus 34 plus minus 34 and plus 7 means minus 27. This is minus 10. This is 7. Then 7 plus 17 is 24. 7 plus 2 into 17 is 41. And these are the elements of 7 bar, means these are the values of x that are congruent to 7 module 17. And now we have to find the values in the range 1 to 100. So list all the elements of this 7 bar lies between 1 to 100. So list all the elements in the range 1 to 100. And so that are what? These minus 27, minus 10 are not in the range 1 to 100. 7 is in the range to 1 to 100. Then 24 element, that is 7 plus 17. Then 7 plus 2 into 17, that is 41. This element 41. Then 7 into 7 plus 3 into 17, that is if you substitute z as 7, k as 7 in this 3 in this formula, that x is equal to 7 plus 17 into k. So we have 7 plus 3 into 17, 7 plus 4 into 17, okay, then 7 plus 5 into 17. So these are the elements lies in this range 1 to 100, and these are congruent to 7 module 17. We check that is it this 58 congruent to 7 module 17. When 58 congruent to 7 module 17, if 17 divides to 58 minus 7, so what is 58 minus 7 is 51, and 17 divides to 51. So check these are the elements which are congruent to 7 module 17. So this is very simple example, that is find the x values of x that satisfies this inequality, this relation. Then same question, that have to find the same question, that list. What is the previous example? This is the previous example, that list all the integers x such that in the range 1 to 100, and that satisfies this relation, that x is congruent to 7 module. Same type question, list all integers x with minus 10 to 90. What is the range? Minus 10 to 90, which satisfies the relation x is congruent to 7 module 11. So when x is congruent to 7 module 11, when x is congruent to 7 module 11, if 11 divides to x minus 7, when x is congruent to 7 module 11, if 11 divides to x minus 7, and when 11 divides to x minus 7, if x minus 7 expressed in the form 11 into some integer for some k belongs to z, and therefore x is equal to 7 plus 11k. Now we substitute values of k from set of integers, and we get 7 bar, that is the equivalence class of 7 bar. So what is the equivalence class of 7 bar? What is the equivalence class of 7? Our residue class of 7 is denoted by 7 bar. This is the residue class of 7 module 11. That is, what is the set? Is the set of x from z such that x is congruent to 7 module 11. That is, the element satisfies this property, that x is equal to 7 plus 11k. And substitute k as integer. So substitute first k as minus 3, suppose value from z. Substitute k as minus 3. Then 7 plus 11 into minus 3. Okay. Then substitute k as minus 2. Then 7 plus, that is the value of z from this, minus 2. Then what do we have? 7 plus 11 into minus 2 means what? We have answer minus 22 plus 7 means minus 15. Then substitute k as minus 1. After minus 2, substitute minus 1. Then what do we have? Minus 11 plus 7 is minus 4. Then substitute k at 0. K at 0. Then what do we have? 7 answer. Then substitute k as 1. 11 plus 7, that is 18. Then substitute k as 2. Then we have the answer 29. Then substitute k as 3. Then we have answer 40. Then substitute k as 4. Then we have the answer 51. Then substitute k as 5. Then we have the answer 62. In this way, we have the answer. Substitute k as 4, 5, 6, 7, 8. And what are the elements of this 7 bar lies in this range minus 10 to 90? This minus 15 is not in this range. So from minus 4, then 7, 18, this 29, 40, 51, 62, 73, and 84. These are not, 95 is not in this range, minus 10 to 90. So these are the numbers, integers, which lies in this range and satisfies x is congruent to 7 module 11. So this is the example. The previous one is what? We have to find the integers in the range 1 to 100, and that satisfies x is congruent to 7 module 17. So when x is congruent to 7 module 17, if 17 divides to x minus 7, and x minus 7 is equal to 17k, that is when 17 divides to x minus 7, if x minus 7 expressed in the form 17 into k. and that is x is equal to 7 plus 17k. Substitute k as minus 3, minus 2, minus 1, 0, 1, 2, 3. We have these elements of 7 bar. So this is 7 bar, residue class of 7, module 17. Okay, and these are the elements of the 7 bar, minus 27, minus 10, and the elements rise in the range 1 to 100 are what? 7, 24, then 41, then find next element 58, 75, 92. These are the elements lies in the range 1 to 100, and that satisfies the relation x is congruent to 7 module 17. So both the problems are of the same type. Then next problem, if p is prime and a square is congruent to b square module p, then show that p divides to a plus b or p divides to a minus b. So a square is congruent to b square module p implies p divides to a square minus b square. And what is the factorization of a square minus b square? A plus b into a minus b. And then by p is prime, then by Euclid's lemma, what we have? P divides to one of them. Then p divides to either a plus b or p divides to a minus b. Because p is prime and p divides to a into b. Suppose p divides to x into y. Then either p divides to x or p divides to y by Euclid's lemma. Then find the remainder when 2 raised to 50 is divided by 7. So this is the question, that find remainder, the same type questions. Here is the question. We see first this question, that show that 41 divides to 2 raised to 20 minus 1. Okay, so show that 41 divides to 2 raised to 20 minus 1.
Hello. Hello.
So we start with this 32 is congruent to minus the answer given in the two method. The first method is this, 32 is congruent to minus 9 module 41. Because 41 divides to 32 minus 9 means 32 plus 9. So 32 plus 9 is 41, and for 41 divides to 41, therefore 32 is congruent to minus 9 module 41. We start with this, or we start with this. 2 raised to 5 is congruent to minus 9 module 41. Which we find these two numbers randomly such that this number is congruent to this number module 41. That is, take here some number, here some number, and we try to write that this number, the subtraction of this minus this is divisible by 41. That is 2 raised to 5. 32 means 2 raised to 5 is congruent to minus 9 module 41. Then take the fourth power of both sides. We have to find 2 raised to 20. So 2 raised to 5 raised to 4 means 2 raised to 20. And then minus 9 raised to 4 module 41. That is, take the fourth power of both sides. And then 2 raised to 20, 2 raised to 5 raised to 4 means 2 raised to 20 is congruent to minus 9 raised to 4 is what? Is minus 9 square into minus 9 square, or minus 9 square raised to 2. That is 81 square. And this 81 is congruent to minus 1 module 41. Because what is the answer of 81 minus 1 is 82. 41 divides to 81 plus 1. That is 82. And therefore, what we have? 81 square is congruent to minus 1 square, taking square of both sides, module 41. And then 81 square is congruent to 1, module 41, because minus 1 square is plus 1. And therefore, 20 raised to 2 raised to 20 is congruent to 81 square, module 41, and 81 square, module 40 is congruent to 1, module 41. And this congruence relation is an transitive relation. That is, if A is related to B, B is related to C, then A is related to C. So 2 raised to 20 is congruent to 1, module 41, because the relation is transitive. That is, if A is related to B and B is related to C, then A is related to C. 2 raised to 21 is congruent to 81 square. And 81 square is congruent to 1, and therefore 2 raised to 20 is congruent to 1, module 41. And therefore 41 divides to 2 raised to 21, 2 raised to 20 minus 1. by using the definition of when A is congruent to B module n, if n divides to A minus B. So we have 41 divides to 2 raised to 20 minus 1. Another proof of the same, that is, we start with 2 raised to 5, that is 32, is congruent to what? Minus 9 module 41. Then taking fifth power of fourth power of both sides, we have this, and 9 square into 9 square, 81 into 81. 81 is congruent to minus 1. 81 is congruent to minus 1 module 41, because 81, why 81 is congruent to 1 module 41? Because 81 minus 1 is plus 80, plus 1, that is 82, and 41 divides to 81 minus, right here, minus 1, and therefore minus 1 into minus 1 is plus 1, like this. And then 2 raised to 20 is congruent to 1 module 41, and therefore 41 divides to 2 raised to 20 minus 1. We can solve these examples by using different methods. So this is the example. Find remainder where 2 raised to 50 is divided by 7. So here 8 is congruent to minus 1 module 7. It is congruent to minus 1 module 7. Why it is congruent to minus 1 module 7? Because 7 divides to 8. Here is write plus 1. So write here plus 1, because 8 minus 1 becomes plus 1, 9. So write here plus 1. So 8 is congruent to plus 1 module 7. Right here 8 is congruent to plus 1 module 7. Then taking 8 means 2 raised to 3. It's congruent to 1, right here also 1 module 7. And then taking 16 power of both sides, because we have to find 2 raised to 50. So taking 16 power of both sides, here is right, plus 1 raised to 16, and then this is 2 raised to 3 raised to 16, means a raised to m raised to n is a raised to m into n. This is 2 raised to 16 into 3, that is 48, is congruent to 1 module 7. And then multiply by both sides by 2 square. We have this equation, that is 2 raised to 48 into 2 raised to 2 is congruent to 1 into 2 raised to 2 module 7. And then we have 2 raised to 50 is congruent to 4 module 7. And therefore 7 divides to 2 raised to 50 minus 4. What do we have? 7 divides to 50 minus 4. And so if we divide 7 only to 50, 2 raised to 50, then 4 is the remainder. When we have this, 4 is the remainder, because 2 raised to 50 is congruent to 4 module 7, implies 7 divides to 2 raised to 50 minus 4. That is, if we divide 2 raised to 50 by 7, then 4 is the remainder. Because when what is this equation indicates, that this 7 divides to 2 raised to 50 minus 4. That is, if we subtract 4 from 2 raised to 50, then we say divides. And so 4 is the remainder when 2 raised to 50 is divided by 7. So this is of the same type example. We'll see in the next lecture.